In these next two examples, you'll see that we do not have all four characteristics of the sinusoidal function transformed. We only see two in each of these. So in this first equation, we see the amplitude has changed and the period has changed. That means the sinusoidal axis stays at 0, where it normally is for just a cosine function. And the phase displacement also stays at 0. So this is the amplitude here. Amplitude equals 3. On the x side, we see that the phase displacement, there's nothing added or subtracted inside the function. So that means the starting point is still at x equals 0. That's our phase displacement. And that's going to be the starting point of the cycle in the x direction. But the period is changed because b is 2. So b is equal to 2, which is equal to 2 pi divided by the period. Well, if 2 is equal to 2 pi over the period, that means 2 times the period is 2 pi. So the period has to be pi. So the period equals pi. 2 pi divided by pi would give me 2. Another way of looking at it is if you multiply by 2 inside the function, it makes the period be half as wide. And since a cosine graph normally has a period of 2 pi, half of that would be pi. So when we draw this, we just need to put the sinusoidal axis. It's actually going to have go through the point 0, 0. Well, it's going to have the point 0, 0 as kind of a center point of the graph. The graph goes up to 3 and down to -3. And its starting point of the cycle is 0, and the ending point is at pi. And when I say the ending point of the cycle, it doesn't mean the cycle has a point there. I should have just said the cycle's ending x value is pi. Because this is a cosine cycle, and a cosine cycle does not start and end on the sinusoidal function or sinusoidal axis. A cosine function starts high and ends high. So the first point would be at 0, 3. This last point would be at pi 3. The middle point, we need to have a middle value on our x-axis. So halfway between 0 and pi would be pi over 2. That would be where the middle point is, and that would be the low point on a sinusoidal, or on a cosine graph. And then we need something halfway in between each of these for the point on the sinusoidal axis. So halfway between 0 and pi over 2 is pi over 4, 1/4 pi. Halfway between 1/2 and 1/2 is 3/4, or 3 pi over 4. And I could have also written this as 0.5 pi, 0.25 pi, and 0.75 pi, and that would have been all right as well. So these 2 points are the key points on the sinusoidal axis. So here's my cosine cycle. Remember drawing concave down above the x-axis, or above the sinusoidal axis, and concave up below. So there's one cycle for cosine, and that's all you need to draw is one cycle. This on example number 2 or 3 here. Example number 3, notice we have something added outside the function but not multiplied. We actually do have a multiplied number. This would just be 1 here. So we could think of this as -3 plus 1 sine of 1/3 times x minus 0. So if you want to fill in some numbers, the 0 is always assumed when you don't add or subtract anything, and the 1 is assumed when you're not multiplying anything. So we could write it out like this and see what all those numbers are. So here is sinusoidal axis, -3, amplitude is 1, phase displacement or starting point is at x equals 0, and we see we have a 1/3 in here, which means that the period has to be 3 times bigger than normal. In other words, b is equal to 1/3, which is also equal to 2 pi divided by the period. And so the period is going to have to be 6 pi, because if 1 is 2 pi, then 3 times 1 is going to be 6 pi. Another way we could do this, I'm just going to write this, and I'm going to take up some space and then erase it. But I could say if b is 1/3 and that equals 2 pi divided by the period, I could just call the period p, and then I could say p times 1 is 3 times 2 pi, just solving the ratio, and I would get that the period is 6 pi. So What's my high and low point? What are my high and low points going to be on the y-axis? Well, since the sinusoidal axis is equal to -3 and the amplitude is equal to 1, the high point is going to be -3 plus 1, which is -2, and the low point is going to be -3 minus 1, which is -4. I'm going to start at x equals 0, and I'm going to end on the x-axis as x equals 6 pi, because that's the ending the ending x value of the cycle. That's the period in this case. So, drawing this, I don't need anything above the x-axis because all my y values are going to be down here. -1, -2, -3, -4, and my key points are at -2, -3, and -4. Here's the sinusoidal axis, and the amplitude will take me up to -2 or down to -4. On the x-axis, here is 6 pi, here is 3 pi halfway through. Then I need to go halfway between each of those to get my other key points, because remember I'm starting when x is 0 for my cycle and ending at 6 pi. So this would be 1.5. Halfway between 0 and 3 pi. Halfway between 3 and 6 pi would be 4.5 pi. So that's perfectly all right to use decimals in front of the pi as well. Now this is a sine function rather than a cosine function. We see in the graph this is sine, which means my first point and my last point and my middle point are all going to be on the sinusoidal axis. So there would be point for the first point, the middle point, the last point. Then I'm going to go up to y equals -2 and down to y equals -4 with an amplitude of just 1. There is the sine cycle. What I want you to notice too is that when pi does not appear in the b value that's multiplied inside the function, pi is going to appear on the x-axis when we're in radians.